Well, my name is William Chia. I am part of the product team at GitLab from San Francisco, California. And today I hope to talk to you a little bit about write once, run anywhere serverless. So just a bit about me. As I mentioned, on the product team. I am on various social channels, so I'd love to connect with folks in the room. And then, of course, please do take out your phones. My Twitter handle is @TheWilliamChia, so if you tweet out, after the talk, I'll be happy to retweet and engage with conversation. And I believe the hashtag is ServerlessCon for the conference, so you can use that. And the state of multi-cloud serverless. So today, as we've chatted and heard a little bit about this morning already, or even just in the serverless space, using, say Lambda versus Google Functions versus Azure Functions, there's quite a bit of unique nuances between each of those. And if you want to port your workloads from one to another, it's a non-trivial amount of work. So what would it look like if you could actually define your functions once and then be able to run them on any type of compute you wanted, even on-premises compute? This is the promise that we'll talk about today using open source technologies like Kubernetes, Knative, and GitLab Serverless. So just a kind of roadmap of over the next hour, chat about GitLab a little bit. Hopefully there's some surprises, even if folks are familiar with GitLab. Maybe there is some new things. Actually, I'm kind of curious, how many folks in the room have used GitLab previously? Okay, so almost everybody. And as I mentioned, maybe if you haven't used it in a while, there's some new things in there. Talk about Kubernetes, cloud native. I have a bit of a demo where we can walk through GitLab Serverless and then hopefully open it up to some Q&A. So what is GitLab? When a lot of folks think about GitLab, this is a typical tool chain where you would want to do some software development, delivery, and operations. And a lot of businesses use this, type of tool chain. In fact, you might actually have this exact tool chain where you log some issues in Jira. Maybe you've got GitHub and you do some builds in Jenkins, et cetera. And most folks know that GitLab is a source code management tool, and you can plug it into the stack there. Now, that is a place you can use GitLab, but we also have world-class CI. And so I'm kind of curious, how many folks have actually used GitLab CI before? How many folks have used GitLab CD? Okay. We also have a whole suite of agile planning tools built into GitLab. We also have an artifact repository and container registry built into GitLab. We also have security application testing built into GitLab. As you may have guessed, we actually have functionality in all of these categories. And so the reason I want to make this intro is to say, when I'm talking about serverless or from the GitLab perspective, we are thinking about this experience of having a single tool chain for the whole software development lifecycle. Now, folks definitely use us. These are other great tools, and we love to play well with others and integrate with these other tools. And folks can and do use us together as integrations. The idea of GitLab is to be able to use it for as much or as little as is useful to your use case. But some things start to happen when you are using that whole stack together. In fact, this is a current picture of our homepage. These are all of the capabilities that we have today and are planned coming up in GitLab. So you can see there's a lot of functionality there. You might ask the question, why do you keep adding functionality into this one single experience? Well, we kind of stumbled upon it. We didn't set out to do this, but kind of by happenstance or by luck, came across this model. So originally, GitLab SCM and GitLab CI were two separate projects. And as an open source, project, we wanted to merge those code bases. And the main argument to merge the code base was, hey, it'll be easier to release. It'll be easier to maintain one code base versus two. We should really integrate these into a single application. And so we said, OK, this will be more efficient. We'll go and do that. But as soon as we went to market with that model, the market really loved this model of having your source code version control and your CI/CD in a single application. All of a sudden, all of these kind of meta benefits start to emerge. So for example, you can actually view your pipelines right inside of a pull request or merge request. All of a sudden, when you are trying to do DevOps and have a development team collaborating with the operations team or a DevOps team, and you're using a single tool where everybody has the same view, one source of truth, one data store, one authentication, instead of having to open up 5 tabs and open up 5 tools, this kind of workflow really, really resonated with people. And I hear all the time from GitLab users and customers that they really love this experience of having everything in a single application. So we kind of stumbled upon that. We've kept on building that. I bring this all as just a matter of introduction to say that when the way we're thinking about serverless, and in particular GitLab Serverless, as you can see, actually there is a slot there in our configure stage for GitLab Serverless. And this is a pretty recent feature we've shipped. We're thinking about that functionality within the context of this single application. So with that, just to chat a bit about Kubernetes, thinking back to the early days of container scheduling, there was a few options on the table. There, you had Docker Swarm, Mesos from Apache, and these tools still exist. But when GitLab looked at that market, we made an early bet on Kubernetes. And we said, we really think that Kubernetes is going to excel and take over the market in this space. And so we, in a very early stage, integrated Kubernetes into GitLab and actually have some pretty nice and advanced Kubernetes functionality because of that early adoption. Well, as the market started to evolve, it just so happened that, yeah, Docker said, well, you can use Kubernetes and Docker Swarm, and Mesosphere said, yeah, you can use Kubernetes as well. In fact, it kind of seemed like every cloud provider out there said, hey, I've got a Kubernetes too, right? So everyone from Amazon, Rackspace, IBM Cloud, everybody has come out with a managed Kubernetes service, and this has really proven out that Kubernetes is the way to do container orchestration. So that kind of leaves it to this, Kubernetes is the way to do it, and I think that kind of market adoption has been great. The way I like to think about it, though, there are all these benefits of Kubernetes. There is container bin packing, and there are various primitives that you can use. There's a lot of nice things, but for, if you're an operations person, for a development crowd, I think the value of Kubernetes is the one attribute is its ability to abstract infrastructure. And so this is actually a concept I stole from Yao, who did Yao and Kenny did the workshop yesterday. It was a terrific workshop, and one of the concepts here was about architecting your applications where you want to write your business logic in a componentized way where you are not leaking implementation details into your business logic. So this is good architecture. That way you can then create abstractions. So if you want to have a model into your persistence, right? You don't want to have inside your business logic call out to MongoDB, right? You just want to say, go store this. And then whatever storage it is, you can abstract that away. And if you are architecting in this way, when you want to abstract away your infrastructure, Kubernetes really solves that problem really, really well. So there's a lot of talk around hey, if you have this problem or that problem, just rub some Kubernetes on it and things will go great. And I don't think it's a panacea. I don't think it's going to solve all the problems. And there's certainly places to use it and places not to use it. But the one thing that it does really, really well is function as an abstraction layer above your infrastructure. And so in a very simple way that almost any business can do, you can run a cluster on Prem. You can run a cluster in any various cloud. And very simply, without a lot of work, now all of a sudden you are multi-cloud. And you have some options where you can pick and choose where you want to run workloads. And especially if they're containerized workloads, then they have that portability of you being able to deploy them to the cluster of your choice. That might be based on the region that it's in or based on a cost model. There's certainly more advanced ways of doing this, trying to have an entire system that is backed by multi-cloud. But at a really simple level, Kubernetes abstracts your infrastructure and really empowers that kind of multi-cloud. And the way that I think about this is the story of Ask Media. So Ask Media is, they are a GitLab customer. We recently did a webcast together. So I was working with Cheng Lim, who's one of their principal architects. He works on all of their cloud native and microservices. And you might remember these folks, they used to be Ask Jeeves, and then they became Ask.com. And today, even though I think it's maybe about a team of 100 or so, but they have 30 different sites globally. They have over 100 million unique visitors per month. So a significant amount of traffic and scale needed to be supported by a relatively small team that needed something to leverage their efforts. And I think that the story that they went through illustrates the power of Kubernetes. Effectively, they were running a monolith on-prem. This is the quintessential digital transformation story. They wanted to move to microservices in the cloud. And I think the way they did it illustrates this infrastructure abstraction story, because they didn't try to bite this all off in one step. They didn't try to eat the elephant. They said, let's eat the elephant one bite at a time. So the first step in their transformation was they took that on-premises monolith, started to break that out into containers and containerize that application. Don't worry about Kubernetes, it's still running on-prem. Of course, then they installed a Kubernetes cluster, but on premises. Instead of trying to jump straight to the cloud, they already had some familiarity with that, running their infrastructure and their hardware. And so they didn't try to bite off cloud as well. They said, okay, we're going to do Kubernetes on-prem. Well, as it so happens, when they got good at doing Kubernetes on-prem with their containers running that way, it was relatively simple to then migrate that cluster to the cloud. Not necessarily trivial, but doable. This was what allowed them to learn this model and then shift it into the cloud, which of course today they now run a full microservices architecture running on Kubernetes. It's running on AWS. And so I think that story of their transformation just kind of illustrates this point that the one thing Kubernetes does well, I'm hammering it in, is infrastructure abstraction. So, which is kind of what this slide also shows. One thing also to note, I think IBM recently came out with a study that 85% of enterprises, or I think in the US we say enterprises, although I believe in Europe, an enterprise is like a small business. You have a small to medium-sized enterprise. And so is there a term that you use for large business? Enterprises as well? Large enterprises. So in Europe, they have small and medium enterprises and large enterprises. So of the large enterprises, 85% are doing multi-cloud. I think if I remember the study correctly, over 90% had plans to do multi-cloud, but only about 40% actually had started to implement a strategy for multi-cloud. So I think that's an accurate picture of the market where multi-cloud is not something you really want to avoid. You don't want to necessarily put your eggs all in one basket, but it's something that is evolving. So with that, I want to get to, okay, great, Kubernetes can abstract my infrastructure, but what about serverless on Kubernetes? How do I do serverless together with Kubernetes? Well, I may have shifted some of my slides around. Or I may have deleted an entire chunk of my slides, which is always fun. Let me just see if I can go back in, this is the beauty of Google Slides, right? Let me see if I can figure out what happened to my deck here. Yes. Okay, we'll just restore this version. All right, my apologies there. I probably selected some extra slides and then deleted them. Okay, so serverless on Kubernetes. So there is definitely this concept here of serverless equals a billing model, right? If I want to do serverless, this means that I want to only pay for the compute that I use, and if it scales to 0, I don't want to pay for anything. Well, of course, what happens if I am running, Kubernetes cluster? It always has to have some amount of nodes in the cluster, right? So I can never really scale to 0 because my cluster is always running on something. I'm always paying compute for something. So you might even say, can you even do serverless on Kubernetes? But I think this kind of model or concept belies the way people might be thinking about serverless, and it's more, slotted towards a startup mentality versus like a large enterprise mentality. And so thinking about the way large enterprises adopt Kubernetes, I think it'll start to make sense. So again, the story here comes from Ask Media Group, but also from others. If you look at folks like Reddit, Pinterest, Fairfax Media, when they adopted Kubernetes and they started to use this, they all use this same pattern over and over again. And whether you read the stories or you're talking to people that have done it, I've seen this pattern happen repeatedly. And in fact, there's hundreds of companies that have adopted Kubernetes, and I'll tweet out the slides after this, and this has the links to all the stories, but I imagine if you dig into any company, you'll see a similar pattern. And this pattern is what I call the Steve Jobs architecture pattern, or we should call it the Steve Jobs wardrobe architecture pattern. And so you got to remember, Steve Jobs, he wore the same thing every day, right? And I actually had a CEO once who got rid of all his other clothes, bought 20 versions of the same outfit, wears the same thing every day. Well, why is that valuable? If you get like a hole in your shirt, you can just replace that with another shirt and everything still fits together, right? So the idea of having a template allows you to have a repeatable process, right? And so in this way, this is kind of like how companies have adopted Kubernetes. So this is the model that I've seen, and it's this idea of generating templates for your development team. So Kubernetes is not the most developer-friendly tool. And in fact, most developers don't want to learn and don't want to dig into that stuff. And in a large business, it does not really make sense to go and train every single team. So in this type of architecture diagram, you might think of each of these lines as a particular service in a microservices architecture. And each of those services is owned by a development team, and they can even own the uptime of that service. But the underlying platform is a Kubernetes platform. And so what I've seen is IT operations teams that own the cluster, they own the infrastructure, they provide that as a service, essentially a managed service in the enterprise, to those development teams as customers. And so if you think about this model when you're in a large business and this starts to make sense for you to start to own some of these things and be able to optimize them, then providing those templates out to those teams so that they can just start adopting, and they automatically have CI/CD, they automatically have a way to deploy their applications, they don't need to worry about it. In that type of model, then at some point you're always going to have some amount of nodes running on your cluster, but for any one particular service, you can in fact scale to zero, right? And so if you think about it in this type of model, in the large enterprise model where the operations team is providing services to the development teams, then if your particular service scales up and down and does scale to zero, it is a true serverless model. So with that being said, okay, how do you do serverless on Kubernetes? There are a lot of different tools that have emerged. Again, we've kind of seen this before. Hey, how do I do this? A lot of tools emerge. But for GitLab, we have made an early bet on Knative. So all of these tools are great to some degree, but we really think that Knative is going to be the way to do serverless on Kubernetes. And this is where we've started. Our vision is in the future to be able to have serverless with multiple components, but we started with Knative. Now, if you were in the last session with Nikhil, he went deep into all of the component parts of Knative. I won't go that deep. I'll just say the three components here, if you weren't in the last session, are you have a build component. This is going to run your jobs. It's going to build your containers. It's going to push that container. Then you have a serving component, and this is the component that allows you to scale up to infinity or down to zero. And then there's this eventing component, and this is what allows you to communicate between services or to trigger triggers serverless functions based on incoming events. And so for GitLab, we decided to use the serving component and the eventing component, and we decided to use our own build. So these are modular components of Knative, and Knative provides these services on top of Kubernetes, and that's what we took in our architecture. And so essentially, you can think of the stack as you have your infrastructure, Kubernetes abstracts the infrastructure. Knative provides serving and eventing the scaling components. And then GitLab Serverless is what provides you a FaaS. And so within Knative, there's not really a concept of a function. When you're using Knative by itself, you build a container, you need to have some type of web server in there. With GitLab Serverless, we wanted to abstract that away so that all you have to do is define a function, and we'll deploy it and do all the rest. We're using Knative to do that. So this kind of brings me to GitLab Serverless, functions on Kubernetes. This was our goals as we developed GitLab Serverless. We wanted functions on Kubernetes. We wanted them to be easy to use, really easy to spin up, and we wanted it to be part of that single application lifecycle. So I may actually go here and, at this point, head into a demo. Now, if you would like to follow along, I have a repository that you can actually access, and it is gitlab.com/WilliamChia/SAC for Service Architecture Conference -demo. So this is a place you can go. It has step-by-step instructions for if you want to actually replicate what I'm going to show you right now. And at the bottom of the README, I've included a lot of helpful links. So what I'll do is I will show some of this parts of the demo. So the first part, if you want to do this on your own, in order to set up the instructions, you start from ground zero, completely new project. You are going to install Kubernetes, and you're going to install Knative. Now with GitLab, we make this super, super simple. You can literally install a Kubernetes cluster with a few clicks. We have an integration with GKE that lets you do that. And we make it really easy to install managed applications such as Helm, or even to install Knative with a single click on your Kubernetes cluster. If I have some time at the end, I might go through that process. But what I've done is I've started out from a repository here. It is an empty repository with a README, but I've already connected up the Kubernetes cluster. I've already installed Knative, and I've set up a wildcard DNS entry for my Knative IP. So what are we going to do to start out? So the first thing is we are going to create a new directory, and what I can do is open up the Web IDE. So this again is I'll do some stuff in the Web IDE. Google has a GitLab has a built-in IDE, but I'll also pull it down and use my own IDE because both are helpful for different circumstances. So to add a new file here, we are going to create an echo directory. And I'm going to call this file echo.js. I'm just going to build a really simple, when I post to an endpoint, I want it to just echo back to me like whatever the string or object is. So I'll create this file, and I will add a function that in JavaScript that, again, is super simple. Takes an input, I'm going to stringify it, and I'm just going to return that. And the thing that I want to show here is the notion that there's no other code. I don't need any special libraries. I don't need to orchestrate anything else. I don't need to think about the platform that I'm deploying to and write my function to keep that in mind. I'm just writing a pure JavaScript function. And GitLab is going to take care of everything else to actually go and run that as a function. So I'm going to go ahead and stage this and commit it to my repo. And then we can see that it is part of my repository there. So now I'm going to clone this repo locally. Let's see, git clone. And I'm going to cd into SAC demo 1. And I am going to cd into the echo directory. Is that pretty big enough? And so what I'm going to do is I'm going to do an npm init. So I can start out with of course, I have a JavaScript function. So I want like a package.json file. I'm just going to take all the defaults. So I get a package.json. And then an npm install so that I get a package.json lock file. So now I have those in my repository. I can see that those are there, and I will add them and commit. To echo. All right, and if I do a git push, I have those also in my repository as well. So the next step is to add a GitLab CI YAML file. So I'm going to add this file here and chat about some of the elements of GitLab CI file. So here I'll use Atom Editor and actually go back up to my root directory for the project, and that was weird. I copied the wrong thing, so let's see. Let's try this out. Let's try Atom dot GitLab -ci .yaml. Okay, so this CI YAML file, which I realized what I did, I copied the contents of the file. So this is the file that defines your pipelines in GitLab. So again, it's built-in CI/CD, and this is a very rich, robust feature set of CI/CD. This has things like caching and artifacts. There's a lot you can do here, but all that you really need for GitLab Serverless is we're going to include a templated file. And inside of that template, I've actually broken out, so we are going to have stages, and we're going to have a build and a deploy stage. So this section here is actually everything that's in the template, but I wanted to break it out for the purpose of this demo. But in reality, when you're using this, we just wanted to abstract this. This is almost like implementation. So this right now is a way that we're building functions, but we could swap that out for something else. So this is kind of how you get this abstraction. So here with this syntax of having a dot in the front, this is essentially what we call like a hidden job, and is a template. So it's a job that doesn't run, and it's just a template that you can use later on in your pipeline definition. And so this is going to be our build stage. It's going to have for our dev environment, it is going to pull an image out of the GitLab built-in container registry. And it's going to use a command line tool that we've built. It's kind of an internal command line tool to do a serverless build. Then to deploy, it's going to have a similar deployment. And then this is what it looks like to extend those template definitions. So here is where I have my build and my deploy. And really, I'm just extending these base templates. And the only thing that I'm adding is I'm saying, hey, I want to deploy to production instead of deploying to development. So I could extend this with additional logic, et cetera. But really at a level, if you just kind of imagine that you don't need any of this stuff, it's just a few lines in your CI YAML file, and this is provided to you in GitLab. The other thing I'm going to need is a serverless.yaml file. So I will create my serverless.yaml file and open it up in Atom. And this is the file where you are going to be able to define your functions, and it's a really simple syntax. So in Kubernetes, there is the concept of a service. And so for our purposes, we're just going to have a service, and you could name this whatever you wanted. We could just call this like our good times service. And it's going to deploy functions from GitLab using Knative in the Hake for the win. So this functions is where you're going to list all of your functions. I've only got one in here now, but you could actually define multiple functions. And what this does is GitLab not only uses this file to figure out the structure and deploy those functions, but it also is going to present them in the UI, and I'll show that in a bit. So here we can just name our function. We're going to call it an echo function. The handler is going to be the method that I execute. In this case, I don't necessarily have a method. I'm just exporting one function out of my whole file, right? The source is in the echo directory. And then I'm going to have a runtime. And when we thought about this concept of runtimes, we today only have 3 runtimes. So there's a Node runtime, there's a Ruby runtime, and there is a essentially bring your own container image runtime. I should also mention, I don't think I have at this point, that GitLab Serverless is an alpha. So this is stuff we've recently shipped. We're moving really fast. It is open source. A lot of the contributions have come from our open source community. So expect this to iterate rapidly. And the reason why we wanted to build this concept of GitLab runtimes is because we felt that our open source community would start building these and contributing to them. So in a sense, this one is just a Node runtime where I'm going to run my function. I've got a description, and I can provide some environment variables. In this case, just the name of the function, which will be used in the build script. But you can see this is not like I was in the workshop yesterday, or anybody who's ever built a Lambda function. How many lines of CloudFormation do you need to write before you can even just deploy a single Lambda, right? Like pages and pages to go and configure everything. So we wanted to make this really simple, 11 lines, and get you up and going. So I will save that and commit that to the repo as well. Add CI and serverless YAML, and I will commit that and push that up. And at this stage, now what we should see is in my repository is actually running a pipeline, right? So all I've done here is written a function, just pure JavaScript. I added my CI YAML file, and I added a serverless file. And it's now deploying this thing. It's off and going. So as long as there is this pipeline definition, this GitLab CI YAML file, anytime you commit code to the repo, it'll start to run that pipeline. And this is some of that kind of built-in experience that I was talking about. Here is my code repository, but I've got access into my pipeline. So for example, I can click into this and look at some things. So I can see there's 2 stages. There's a build and a deploy stage. Potentially there could be, each of these only has 1 job per stage, but potentially, if I could have a test stage and it could have many jobs that just all run in parallel. So I can look at this build log as well from within GitLab, and we can see that that one succeeded. And maybe if we catch the next one quickly enough, we can watch the deploy function kicking off. So here you can see it pulls a Docker image out of the GitLab Docker registry. It is going to initialize it, and it's essentially running this command, which, as I mentioned, we call this the GitLab Kubernetes CLI tool. This is not one that our intention is that you would use this for local development. There are other GitLab CLI tools for local development. This is kind of one that we wrote to provide some abstractions to call from within your CI file. And my job succeeded. It's also nice and speedy. We had, like I said, this changed on Friday, and previously it took a little bit longer to build these, but now it's already done. So you can see what it's done is it's kicked out a URL for me here. And this is the URL of my endpoint where I can access my function. The other place that I can get to this is if I go to the Operations tab in GitLab, and there is a serverless page. And this should now be pulling from that YAML file to show the definition, although we'll see if there it is. So here is my good times echo function out of my good times service, and here's my endpoint. So let's actually test this thing out to see if it is running. So I have this curl command. I'm literally just going to curl some JSON and see if this actually works. So at first, it's going to say syntax error. So let me get my endpoint out of GitLab, which is here on the serverless tab. So I'm just going to copy that endpoint there. I'll pop that into my curl file. And I should send, right now I just have an object that is GitLab FAS. So let's just call this one Serverless Architecture Conference. And some kind of string or phrase. What do y'all think of the conference so far? Nice. It is nice? All right. Nice like ice. Ice, baby. So if all goes well, it should actually echo that phrase back to me. Went through it pretty quick. Let's find out. And there we go. So I don't even know how long that took, but I think in about 7 minutes from 0 to getting response running on Kubernetes function. Really, really simple and easy to deploy. So the next step is, okay, that's great. I have a function, but you know, it's kind of bare bones. Maybe we should take advantage of some of these kind of built-in tools. And I probably want to write some type of unit test. So this is kind of, again, where you can have everything integrated together. What does that flow look like, right? Well, GitLab has this kind of built-in issue tracker. So I'm going to create a new issue. And this is where I might do my project planning. What do I need to do? And this is going to be add a unit test for your function. And I'm probably going to have some kind of description, like TDD says you totally should have made this first. Do you even DevOps? And you know, maybe I'll assign myself. So here I'm just still kind of in my planning phase. I have an issue. Maybe I can set due dates or milestones, labels, whatnot, and have conversation about the specification. And then the idea here is because the issue tracker is completely coupled to the source code management system, I'm just going to go ahead and start a merge request. So I'm just going to, right from the issue, I click on create merge request. And it's going to tell me that it failed to create a merge request. But it actually didn't. I'm not sure why I got that message. So here's my merge request. Now, this is probably a different flow than you're used to. How many folks, when you are going to add a feature, start with a local branch, build your feature, and then when it's ready to show off, then you create a PR? Okay? How many folks create the PR first with nothing in it and then start developing? Okay, so this is how we do it at GitLab. We call this GitLab flow. So the idea is you create the merge request first, totally empty merge request. You say, why would this be helpful? Why would I open the PRs? PR, MR, it's the same thing. Why would I open the PR so early? Well, this is to really, really do agile, DevOps iteration, and for the sake of transparency. So, for example, what I can do is I can check out this branch, and I'll go locally. So let's check out what branch I'm on. OK, I'm on this add a unit test branch. And there's a few things that I am going to want to do in the instructions. So the first up, let's add a gitignore file. And let's just stick node modules. Is that right? Node modules? Because we don't want to commit those. Yep. And then we are going to want to install our testing framework. So here I'm going to say npm install mocha. And then I will do an npm init again. This is going to give me my package.json file. And this time I'm taking all the defaults. But of course you can see it has a test command because I've installed Mocha. So now my package.json is going to run tests out of Mocha. And this is, of course, is Node, but if you're using Ruby or Python or whatever your language of choice is, you could use your testing framework of choice. And I'll take all of those defaults. And then I want to update my GitLab CI YAML file. So here in my pipeline definition, I'm now going to add a stage called test, right? So this is where I can define each of the stages in my pipeline. So I'm going to add a test stage. And I want to add a test job. So actually, it'll look like this. So this could be as complex as you wanted. Essentially, the way GitLab works is it has an agent that runs your jobs. We call it GitLab Runner. And that agent is essentially a Linux-based executor. So anything that you can script or anything that you can bash, you can run in your pipelines. So here, I'm really just pulling a node-based container image. Then I'm just doing an npm install, and I am going to run that Mocha test with this echo. So the last thing I need to do is actually add the test file. Let's see, echo, and we're going to call this test.js. And I'm going to run the simplest test that there is. Essentially, I'm importing my module. I'm using this assert. And then here where I'm describing the test, I'm literally just saying, is a JSON.stringify message, because this is just an echo function, is that going to be equal to me running the echo function and passing in that message? And instead of saying hello from GitLab Serverless, we can say hello from the serverless conference in the beautiful The Hague. And actually, it's called The Hague, right? So would you say the beautiful The Hague, or would you say the beautiful Hague? I don't know which one it would be. I'm going to say the beautiful The Hague, like I would say the beautiful San Francisco. So I've committed my test, and now I can stage all of these things. Or actually, let's say I didn't even stage all these things. Let's say at first, I just added the gitignore, right? So here is my commit message, and I can say add gitignore. And if I commit that and push that up, now you can imagine this is just like, very simple development. This is kind of demo and want to make it very, very understandable. But if you look now at my merge request, right? This is kind of where I was saying start with this empty merge request. Now my merge request has one commit in it. And in this case, it's really simple, but if you're doing development in a team and you want to see the progress of your teammate, right? You kind of want to know where they're at. If that is all in your local repository and then you wait until it's ready before you do the pull request to do any type of kind of code review, then you could have this like really huge code review, and then you're kind of begging everyone, please somebody do code review, and nobody wants to do it because your PR is too huge. Or in another case, if you're doing something that is not smart very early, right? And maybe a teammate happens to look at it. So this is like an active visibility, right? As you might have, different commits here, add packages, and then this might be update CI. And then finally, we can say add the test and push all those up to the repo. So here in the merge request, you can see I've got all of this kind of commit history. So the idea is as it's evolving, folks can see the progress that I'm making on something, see the iteration, and also I can get feedback earlier in the process. So you can totally use GitLab in the way that is, I write all my stuff, I create a branch, and then when I'm ready, I go create a merge request. But this flow here, where you start with the merge request, this is something I use every day, and it's a really, really cool experience. It has nothing to do with serverless. I'm just, I don't know, it's something fun. So that's just bonus. So all that's to say is now you can see in the merge request this kind of unified experience. So I went from issue to coding to code review, talked a little bit about that. And now the pipeline is running, and of course I have my pipeline right in my merge request here, and it's doing all the same stuff. Well, it's gonna build first that job succeeded, but now I have my test phase where it is actually gonna run my unit test. So let's see. I think everything was tested ahead of time, so this totally should work. Let's find out. So it's pulling that node Docker image. It should now run an npm install, and we can see this updating in real time as it goes. See, this is interesting. This mocha test actually takes longer than it does to build the function. Which is kind of nice that function is a very svelte or unique thing. And something else that I can do is we've got this concept of a WIP merge request, work in progress. So as long as it's got this WIP status, the merge is grayed out. No one's going to merge it. And so this again is like if you start your merge request and it's got nothing in there, and then you just add a little bit. Well, you don't really want someone to merge that because they could just break things. Right? So that's why we use that work in progress to say, hey, don't break things. But in this case, I think this one is ready for prime time. So I'm going to resolve that status. And now I have a merge button. And what's nice is I just want to do some continuous delivery. Right? I don't really want to check or manually gate. I'm just going to say, go ahead and merge this to master when my pipeline succeeds. So I'm just going to trust my pipeline, trust all my tests. And actually, look at that. My test passed. That is phenomenal. It's now going to deploy my function, and it's waiting for my good times echo ready state. So as soon as that deploys, there is one last thing that will pop up here. I'll just let it go, and maybe we'll come back to it. What'll happen here is once this pipeline passes and then it's complete, I thought what it'll do is it'll actually show on the master branch where it starts to run the pipeline. So you have kind of all in one place to do your development of functions. And so again, this is right now we've got this alpha feature. It's pretty lightweight. There are just a couple runtimes, and it's alpha functionality, but it is open source. We are getting community contributions. We're moving very quickly. And this is the opinionated way of how building serverless sits within your broader software development, from planning and testing to deployment. So with that, we're just going to let that run. And I would love to, let's say, I don't know, we have about 10 minutes left, and just kind of have some dialogue and some questions. So any questions?
So I had one question. It's the demo was great, and I really used your CI/CD pipeline, and it's really beautiful. But the question I had is, for example, if you build our pipeline and we deploy our function, what is there beside functions for us to use? Because the serverless concept is a bit bigger, and we really benefit from using other services, like for example in AWS we have Kinesis and S3 storage and etc.
Yeah, so I'll repeat the question because I think when on the recording it'll go through the mic. But the notion is, okay, hey, this is great. I have a function in my pipeline, but what about integrating into things like Kinesis or DynamoDB or any of these types of other managed services? And to that, to be completely candid, AWS is always going to have a leg up on integrating with other parts of AWS, right? And this is a reason to start to use Lambda, natively because it kind of has all these easy built-in hooks. All that's to say is you can totally create an API gateway and access everything from GitLab CI. So in fact, we have one of our customers called Trek 10. They actually have a webcast that's coming up later this month. They're doing an entire webcast on they're a big AWS shop. They use a ton of Lambda, and they are doing, they have like this very complex, sophisticated CI YAML file that uses Terraform to get into all of these AWS services and actually to deploy your Lambdas. So that is something that's totally doable from within GitLab CI/CD. In that case, you're not even using the GitLab Serverless component. You're just using GitLab CI/CD. But yeah, I've shown like a very, very simple pipeline, but that tool is powerful enough to do anything you want to do with CI/CD.
So am I right in understanding it's bring your own Kubernetes cluster, or?
Yeah, so I'll repeat the question. Is it bring your own Kubernetes cluster? That is exactly what it is. So literally, our CEO will say something like, if you are a startup and you want to, write software and deliver it, all you should need is GitLab and a Kubernetes cluster. So essentially, yes, like for us, we're not in the business of trying to provide compute. The idea is any Kubernetes cluster anywhere. It can be a bare metal. It could be on GKE. It could be on an EC2 instance that you've defined that cluster. Any type of cluster at all, you can connect it to GitLab, and it has this ability to just deploy that cluster shows up as a deployment target within GitLab. Or if you do the integration, then, so for example, you could create a cluster, let's say in EC2, and then connect it to GitLab via the GitLab Kubernetes integration. Then you can one-click install Knative to that cluster using the integration. And then you could actually use GitLab Serverless as well. So it is bring your own Kubernetes cluster.
I have one more question. So you showed us this notion of runtimes, right? And you said that for now, you have the Ruby runtime and the JavaScript runtime. So can you please explain how, for example, I myself can help on building those runtimes, and how can I, as a developer, test my images if they actually fit your pipelines and YAML files and etc. Because I myself had some troubles with configuring the YAML files, and I had a lot of actually commits just to fix the YAML file itself, so the build pipeline actually is running good.
So yeah, so if I understand the question, it is where are the runtimes, and my build actually failed. So maybe I'll troubleshoot that after the talk, and we can get that going. But the basic question is, where are the runtimes? How can I start developing runtimes? So part of the answer to that is we just shipped that runtime functionality Friday. So I literally, as I was preparing for this talk, I had built my entire demo, and they merged code on Friday that significantly changed how everything works, so I rewrote it over the weekend. But all that's to say is we can take a look here at the serverless docs, and there is, I don't know if I can dig it up on the fly. What I'm going to do is I'm going to find the link to where the runtimes are, and I will add it to this repository. So if you just go to this, William Chia SAC-demo repo, I'll add the runtimes as a link here. I am going to see if I can just pull it up quickly enough. Yeah, I don't think I'm gonna find it super fast. There is a couple of concepts. Something that I didn't even mention is that I only showed off the functions part of GitLab Serverless. There is also, if you're not just writing a discrete function, maybe you have an entire application and it has a web server and everything, and you just want to pipe that into a container, but you want to, and you can deploy that today using GitLab, and we actually have pipelines to just deploy your containers to Kubernetes, but then it's just running all the time. it's not going to auto scale up and down. So let's say you have an application that is a full application, it's not just a function, but you want to take advantage of the scaling, you could actually deploy applications as well, and there's more info in our docs for that. I just saw that talking is basically you can bring a Docker file. So I am just seeing if these is in the example project. I don't think it's going to be there. I am going to try one other thing. I think here is the project. So let's just, this is a really, really good question. So here's the repository, and then what I'll do is I'll link that back. So here's the runtimes we have today. Actually, there's only Ruby and Node, and soon there should be coming Docker image, but you can see how these are built. So this runtime actually is really, really simple. This is like a very simple Docker file, and that's the whole JavaScript runtime. So if you wanted to add a C# runtime, this is about the amount of effort it would take, and you could actually submit a merge request to this repository, and that's part I love about open source. Any other questions? Cool. Well, I want to say thank you, everyone, for hanging out, and we'll look forward to chatting with you more.